Good day everyone, I am Lloyd Agonia from BSEMT MR3P1 and I'm going to show you my midterm project, which is a Webot simulation of a hexapod robot. So let's open Webot. Here you can see my hexapod. I named my hexapod Vandor, so Vandor the hexapod. And here you can see this is the node, robot node. These are just default nodes. You can add this using this plus sign here, base nodes, and you don't need to go to base nodes. You go to proto nodes and then objects, and then backgrounds. As you can see, I've already added, so they're no longer available here because I added them here. So that's that. Except that, and here's the robot. The robot has a 7 parts. It has the body and the 6 legs. Each legs has 3 joints. So this hinge, the first is the body, which is all these 6 joints are connected to a body. So as you can see here, the children, and also this is the body. Here I snapped it and I anchored it to this body's location. So all these legs are now snapped into the body, as you can see, and same goes to the other ones. And then there's the device. This would be important later for the coding part, and as you can see, I've named them. You need to name them. It depends on you on what you name them. And let's go back here. It's the same for all the legs. So, and here's my physics. I added the physics. So here is the density is -1 because in Webots you can either use the mass or the density. Once you use the mass, the density won't matter, so it's set to -1. So I added a center mass and the inertia, and that's it for the physics. And then here in my controller, since my hexapod has since in Webots it has no program for a default hexapod, well, the Webots has a example, which is the Mantis hexapod. As you can see, some of its parts are based on the Mantis hexapod. I just added some few shape to it, so it would not look like the Mantis, but it's similar to the Mantis hexapod. But the difference is, so this hexapod is different because unlike the Mantis, where the Mantis is when you run the simulation on a Mantis, it just walks in circle automatically and you can't control it. So it's programmed that way. So for mine, I added a custom code here. If you're wondering how to add a custom controller, you can just go here to wizards and then new robot controller. After that, you just next it and then play use whatever language you want to use. So for mine, I just use the C++ language, and you can choose whatever you want here. I just cancel it because I already have. And then if you want to edit it, I just edit it. So I'm going to move it here, and then as you can see, I have my controller here, and then this is just a note text. The program starts here. I added a studio library and the keyboard, motor, and robot H. So these are crucial so that I can run my code without any problem. It's just a default libraries in Webots, so you can call them if you want. You just need to say include, and then this symbol right here, the greater and less than symbol, and then name the file. It will automatically include it when it's highlighted red. That's it. And then first I added a static integer, which is time step. A time step is similar to a millis. So if you're not familiar with a millis, and in Arduino, a millis is as you see the timer here, every time you run a simulation, or in Arduino, every time you boot up on Arduino, there's a timer that starts too. It counts how much time from the moment you start the Arduino to until you turn it off. It just records it. You can call it here, same here in Webots, you can call it, but instead of millis, it's called time step. And then you can call it and use it as is a function or a variable in your robot. So I just use the time step, and it will help me in the further code right here. And then I created a loop. This is the first loop, so I created a lot of loops. So this is the first loop. So basically, what this does is just it says if time step is -1, it means that the time step hasn't started. It means that I haven't booted up my robot. It would just clean up and then exit from the loop. But here I created another void loop, which is a passive wait. I've used this passive wait. It's because delay function on Webots. Webots doesn't have delay functions. I'm sorry. So Webots has no delay function. So I've used my own. I've tagged the time step, and then after tagging it, it becomes an integer. Now I can add it to my robot, and then I tagged it with bind it with the passive wait. So every time I need a delay, I just use this time step. This was the purpose of this code. And then here below is a do while loop. A do while loop, it says that it does the step, which is the time, and then starts the time and starts the robot. After entering that, it enters the static void. So this void, this loop is just it shows commands as it says here, shows command. So it just prints text here. As you can see here, it prints text because I forgot to unpause the simulation. So and it shows text, that commands like this. You can customize it if you want, and it depends on you on how you would put what text you want to put it here. And then here we enter the main loop, so integer main. You could use void if you want. I just use main loop. This is the default of given by Webots, so I just used it as default, so it would be more easier for me to identify. And then initialize the robot. This is also default. And then here you can see my first loop, which is show command, with this show command here at the top. So it says that after initializing the robot, show commands. So after it starts up, it shows this command right here, and then starts the time step. And then enables the keyboard, because in Webots you can interface it with any controller you want, but I just choose my computer's keyboard to control the robot, so I just enable the keyboard. This, by the way, this is default function of Webots. As you can see here, I included a library which is called webots/keyboard@h. It means that all the functions you see here in yellow, they are from these libraries. And then after that, I tag the device. So as you can see, I've said earlier that this is very important here in the joints devices. This device is rotational motor, has a name RPC. As you can see here in motor 1, Webots get device is equals to RPC. So it means that motor 1 in my code corresponds to the physical corresponds to the RPC on this robot simulation. So on and so forth. Same goes for every joint and robot. So I tagged them since every leg has 3 joints. So motor 1, 2, 3 are the first leg, and then so on and so forth. Here I added a velocity each of the motor. I added them. You can also just say motors 18 equals to Webot motor set velocity, and then motors 18 here, the device tag 18, and set the speed. But I want mine to individually set them, because in my program I kinda customize each of the velocity of each motor, so to fit my motion movement of my robot. So you can also do that, or you can do individual set. And then after that, it says here that we have initialized the robot, and then after that we just set the position to initial position. So you can see I've named them coxa, femur, and tibia. That's a basic term. These are the terms that is used in mga legged robots, especially in hexapod, quadrupod, any robot that is legged. So there's a fourth one of this. It's called tar, but I didn't use it because I only used the 3 joints. If I used 4 joints, it would have a 4 leg configuration, a 4 joint leg configuration. Here we enter the loop. This is the main loop. I've used you can use the void loop, or you can also use the while loop. Here I just initialize the time step. So says here it's a condition where if Webot time step is not equal to -1, then start this. It says also here that this, if time step is equal to -1, it means that if the simulation hasn't started. But here it says that not function. It means that it's not equal to -1. It can either 0 to incrementing value, positive value. So if it's not equal to -1, then start this loop. So started the loop, I just add another instance, which is integer c. C is just a instance which is a switch function. So I've used a switch function because it's much easier and much cleaner to work with, and it's similar to if statement, but if statement, you have to put a condition in every function you add. For this, if you example w forward, you need to put a if statement, if and then a statement here, and then this one, which takes a lot of time to do. So in order to shorten it, I just use the switch function, and here see the integer is declared here as a switch function, and then after that it runs in this loop. Every time my robot is initialized, it runs through this loop all over again. Here, this is just the basic code. It just runs through them and runs until, if I press, for example, case W, it means if I press W on my keyboard, it would execute this command, all of this until here. And then you can see, so there's a break function. It's similar to if you're using an if statement, you're just going to use a closing bracket to end the loop, or you just use return function, but here I just use the break. But their function is similar. And then same goes for the S and A, D, and then the other controls. That's it for my program. So let's close this. So here we have the robot. Now I'm going to run it now. It does nothing because I still need to press, I programmed the robot to, I still need to press R to initialize it. So I'm going to press R and see it stands up. I say here default position, and it dances a little, and let's say I want to wave it, let it wave. So J is the wave. So now it's waving, and here we have a basic function which you can move. So forward first. Let's just turn it around like that. There you go. Now it's moving forward. Now backward. By the way, I'm using a tripod gate to make the robot walk. There's a lot of gates that you can use. There's a ripple gate, wave gate, and tripod gate, and I don't know the other ones, but for this robot I just made a tripod gate. I just program it to walk in a tripod gate motion. So let's rotate it, and then the other side. With the combination of all these movements, you can control the robot like this. Control. And this now for the special function, as I have added a special moves, I've added here. And then to see that, I just need to press, say here, F. Now this first move is just counting its legs. And then the next one is G, which kind of looks like it's excited. And then the H just dances a little. And then the K, which just rises up the whole body and then sits down, rises up and then sits down. And when I hold the key function, it stays up, but when I lift remove my finger to the keyboard, it just stays it's revert to the default position. And then the last is just the lay or L for sit function, so it just sits down and then goes back to its initial position. And if I press R again, and it just stands up. If I press L again, it just sits, and just if I press K, it can do basically anything. And then if you just press H, and then it dances a little, then you can make it. I can add more moves to it, but it would make my code longer. So that is just for the basic function of this robot, and that is all. Thank you for watching.